In computer networking, a gateway is a node on a TCP/IP network that serves as an access point to another network. A default gateway is the node on the computer network that the network software uses when an IP address does not match any other routes in the routing table. In home computing configurations, an ISP often provides a physical device which both connects local hardware to the Internet and serves as a gateway. Such devices include DSL routers and cable routers. In organizational systems, a gateway is a node that routes the traffic from a workstation to another network segment. The default gateway commonly connects the internal networks and the outside network. In such a situation, the gateway node could also act as a proxy server and a firewall. The gateway is also associated with both a router, which uses headers and forwarding tables to determine where packets are sent, and a switch, which provides the actual path for the packet in and out of the gateway. In other words, a default gateway provides an entry point and an exit point in a network. Example 1: An office network consists of 6 hosts and a router is given as hosts addresses 192.168.4.3, 192.168.4.4, 192.168.4.5, 192.168.4.6, 192.168.4.7, 192.168.4.8, router address 192.168.4.1. The network has a subnet mask of 255.255.255.0, thus the usable network ranges from addresses 192.168.4.1 to 192.168.4.254. The office's hosts will send packets addressed to IPs within this range directly, by resolving the destination IP address into a MAC address through an ARP sequence and then enveloping the IP packet into a Layer 2 packet address to the destination host. Packets addressed outside of this range cannot travel directly to the destination. Instead, they must be sent to the default gateway for further routing to their ultimate destination. In this example, the default gateway uses the IP address 192.168.4.1. which is resolved into a MAC address with ARP in the usual way. Note that the destination IP address remains 192.168.12.3, but the next hop physical address is that of the gateway, rather than of the ultimate destination. Example 2, a network with 3 routers and 3 hosts, connected to the Internet through router 1. Hosts and addresses, PC1 10.1.1.100. Default gateway 10.1.1.1, PC2 172.16.1.100, default gateway 172.16.1.1, PC3 192.168.1.100, default gateway 192.168.1.96, router 1, interface 15.5.5.2, interface 2 10.1.1.1. Router 2, interface 1 10.1.1.2, interface 2 172.16.1.1. Router 3, interface 1 10.1.1.3, interface 2 192.168.1.96, network mask in all networks, 255.255.255.0. If the routers do not use a routing protocol to discover which network each router is connected to, then the routing table of each router must be set up. Router 1, Router 2, Router 3, Router 2 manages its attached networks and default gateway. Router 3 does the same. Router 1 manages all routes within the internal networks. Accessing internal resources if PC2 needs to access PC3. Since PC2 has no route to 192.168.1.100, it will send packets for PC3 to its default gateway. Router 2 also has no route to PC3, and it will forward the packets to its default gateway. Router 1 has a route for this network, so Router 1 will forward the packets to Router 3, which will deliver the packets to PC3. reply packets will follow the same route to PC2. Accessing external resources. If any of the computers try to access a web page on the Internet, like http://en.wikipedia.org/, the destination will first be resolved to an IP address by using DNS resolving. The IP address could be 91.198.174.2. In this example, none of the internal routers know the route to that host, so they will forward the packet through router 1's gateway or default route. Every router on the packet's way to the destination will check whether the packet's destination IP address matches any known network routes. If a router finds a match, it will forward the packet through that route. If not, it will send the packet to its own default gateway. Each router encountered on the way will store the packet ID and where it came from so that it can pass the request back to previous sender. The packet contains source and destination, not all router hops. At last the packet will arrive back to router 1, which will check for matching packet ID and routes it accordingly through router 2 or router 3 or directly to PC1. The packet doesn't return if router 1 routing table does not have any route to 192.168.1.0/24, and PC3 tries to access a resource outside its own network, then the outgoing routing will work until the reply is fed back to router 1. Since the route is unknown to router 1, it will go to router 1's default gateway, and never reach router 3. In the logs of the resource they will trace the request, but the requester will never get any information. The packet will die because the TTL value decreased to less than 1 when it is traveling through the routers, or the router will see that it has a private IP and discard it. This could be discovered by using the Microsoft Windows utility path ping or MTR on Unix-like operating systems, since the ping will stop at the router which has no route or a wrong route. See also, default route, generic command for displaying configuring TCP/IP routing tables on both Windows and Unix clone systems. External links, a Wikipedia definition, the Linux Documentation Project,